Good morning, everybody. Today we are going to start our basic mechanical engineering lecture with the turbines. And we will start it with the Francis turbine. So you can see the pictorial view of the Francis turbine. You can see there is a casing, and that casing is spiral casing. It is circular one. Here the casing is provided, and you can see this casing which is circular in the direction, circular in its shape. Can you see it?
Yes, sir.
Yes, sir.
Okay, so this is the inlet. Okay, and here you can see a pump, a pipe. Sorry, not pump. A pipe is provided over here. Can you see it?
Yes, sir.
एक इकडच्या साईडला या ठिकाणी पाहू शकता तुम्ही की एक पाईप बाहेर आलेला आहे इथे. पूर्ण दिसत नाहीये, थोडासाच भाग त्याचा दिसतोय. कॅन यू सी हियर?
Yes, sir.
Yes, sir.
So I want to show you. Here it is. So this particular pipe is its outlet, and this particular pipe, it is its inlet. Water is coming to such kind of the turbine from the upper side, and that water is running in the spiral shape, in circular shape, radically inside its turbine, and then that water is taken out from another pipe. I want to show you its diagram here, which will make you clear all the ideas and concept about the Francis turbine. So this is the Francis turbine diagram. Okay, so just you tell me whether by looking towards this diagram, can you recall some memories, and can you tell me which diagram was similar to this?
Centrifugal.
Yes, absolutely correct. Centrifugal pump. And its structure is little bit closer to that particular centrifugal pump. So here diagram is in front of you, and now we will just check what is the difference between that diagram and this diagram and its mechanism. So let us start with the sump. So this is the sump of water. It is the sump. It is water storage, but we are not going to suck the water from this particular sump, and that's why we have named it like a tail race. Tail race means what? Whatever water we are going to take inside, जे पाणी आपण आतमध्ये टर्बाइनच्या घेणार आहे, ते पाणी सोडून देण्यासाठी खाली डॅम मधनं येणारं पाणी आपण वरच्या बाजूने घेतो इथं. दॅट इज द बिग डिफरन्स. सेंट्रिफ्युगल पंप मध्ये आपण खालनं संप मधनं वॉटर सक करत होतो आणि वर हाईटला पाठवत होतो. Here reverse mechanism is there. Water from the penstock we are going to take from the upper side, and we will leave this particular water to the tail race. And when we are sending this all water to the tail race, it is transported up to tail race by the draft tube. In centrifugal pump, there was a suction pipe, but here the pipe is known as a draft tube. And what is the difference between suction pipe and this draft tube? Can anybody tell me? Suction pipe and draft tube madla basic difference काय आहे? By looking towards this diagram, can anybody tell me?
सर सक्शन पाईप मधून आपण पाणी वर नेत होतो ना आणि ड्राफ्ट ट्यूब मधून ते खाली आणलं जाणार.
Absolutely correct. But what is the difference? By looking towards diagram about its shape,
It is slightly
Suction pipe
inclined.
state.
yeah. So your suction pipe was just a pipe which has same diameter, and here the strainer arrangement was there, strainer and footwall arrangement. Am I correct?
Yes, sir.
But here you can see draft tube is having its diameter increasing little bit. जस जसे खाली जातो तस तसं त्याचा diameter वाढत जातो. Means area is going to be get increased from the center of your turbine towards the tail race. टर्बाइनच्या सेंटर पासून टेल रेस कडे जाताना त्याचा जो काही डायमीटर आहे तो डायमीटर काय होत चाललेला आहे, वाढत चाललेला आहे. ओके, दॅट इज द बेसिक डिफरन्स इन द शेप पॉइंट ऑफ व्यू, and that's why we are not going to call it as a suction pipe, because here there is no suction action is going to take place. Suction इथं होतच नाही, and that's why from the pipe through which water is sent to the tail race, that pipe is known as your draft tube. The next component is spiral casing. Now casing is very much familiar with you. What do you mean by casing?
shield,
Shield, cover, yes, housing, yes. So the casing is nothing but the cover, okay, and that cover is avoiding leakage of water through the turbine, and all mechanism of this Francis turbine is safeguarded with that particular casing. हे जे मेकॅनिझम आहे या मेकॅनिझमला सेफगार्ड करण्यासाठी, या मेकॅनिझमला कव्हर करण्यासाठी, या मेकॅनिझमचं प्रोटेक्शन करण्यासाठी आणि वॉटर लिकेज अवॉइड करण्यासाठी केसिंग इज रिक्वायर्ड. Then here you can see there are 2 or 3 circles are there. Okay, so there is a first circle which is outer circle. Just a minute. This is the outer circle. Can you see it?
Yes.
yes,
So this outer circle, and to this outer circle start over here, and this outer circle is going to be end over here. And in between, whatever these 2 circles are there, these 2 circles are generating one wheel. हे जे 2 सर्कल्स आहेत, हे 2 सर्कलचं मिळून एक व्हील तयार होतं, एक टायर सारखं स्ट्रक्चर तयार होतं. And that wheel is known by the name of guide wheel. Sorry. तर हे जे व्हील आहे, या व्हीलला म्हणायचं गाइड व्हील. काय म्हणायचं? Guide wheel. And here there are some vanes are attached in between these 2 circles. Here you can see the vanes, and these vanes are named as guide vanes, and guide vanes are fixed. These are not going to rotate. Okay. And you can see that there is one another wheel inside to this particular mechanism, and this is a small wheel. I have indicated it with green particular circle. Can you see it?
yes, sir.
Yes, sir.
Yeah. And here also you can see that there is one wheel, and on that wheel also there are some veins. इथं सुद्धा काही पाती आहेत, veins आहेत. I am indicating with the green color. So this inner wheel is named as runner, and these all inner veins, it is named as runner veins. So these all the veins which I have indicated with the green color are known as the runner veins. And these runner veins are in a rotating position that can move. Guide wheel and guide vanes are fixed, but runner wheel and runner vanes are movable. This is the construction of our Francis turbine. And here from the upper end, water is taken inside to this particular our Francis turbine. Is it understood to you, everybody? Construction?
Yes.
Yes.
Okay. Construction, it is like a centrifugal pump only, but difference is instead of suction pipe, there is a draft tube. And from draft tube, water is sent to the tail race. Then there is a spiral casing in which all mechanism is closely fitted, and casing is provided to avoid the leakage of the water. Then there are two wheels inside. One is the guide wheel and second one is the runner wheel or runner. Guide wheels are having guide vanes, and these guide vanes are fixed. They are not going to change their position, but there are arrangement of the runner vanes, and these runner vanes are movable. Okay, this is the construction of our Francis turbine. Friends, now we will move towards its working. We will see how this particular mechanism works. Now, as I have mentioned to you people, the water is taken inside of this Francis turbine from the upper end. So water is taken from this upper end. And this water is coming with high pressure, so that this particular water is circulated inside this particular turbine. आतमध्ये घेतलेलं पाणी काय होतं, भरपूर हाईट वरून आल्यामुळं ते वेगानं आतमध्ये येतं आणि पूर्ण तुमच्या स्पायरल केसिंग मध्ये ते फिरतं. And when it is just rotating inside this particular casing, these guide vanes are fixed. Guide vanes fixed आहेत ना?
Yes, sir.
So
Yes.
the water is guided, and this water is moving towards the center of this turbine. हे जे पाणी आहे ते फिरत असतानाच काय होतं, गाइड वेन्स ज्या फिक्स आहेत त्या फिक्स असल्यामुळं ते काय होतं, गाइड वेन्स मधनं आतल्या बाजूला ढकललं जातं in this way. And this particular water which is guided through this particular guide vanes is moving towards the center of our turbine, and it strikes on the runner. हे काय होतं, रनर वर येऊन स्ट्राइक होतं आतमध्ये आलेलं पाणी. So to make it more clear, I want to show it. exclusively when water is coming inside, it is coming through the guide vanes and it is striking on runner. या रनरच्या व्हेनवर ते काय होतंय, आतमध्ये घेतलेलं जे वॉटर आहे ते वॉटर स्ट्राइक होतं. In this way. And as water is going to strike on this runner with its kinetic energy, runner is going to start rotating. Runner vanes are going to move and runner will start rotating. And once runner is going to start its rotation, then at the center there is a runner shaft here. That shaft is also going to be get rotated and generator is attached to that particular shaft. So generator will start moving and electricity generates. Then the water, after providing the motion to the runner, it is taken outside to this draft tube, and that water, it is allowed to move towards the tail race, and from the tail race that water is transported to the next destination. In this way, such kind of the Francis turbine works. परत एकदा मी सांगतो, पाणी आतमध्ये घेतलं जातं, आतमध्ये घेतलेलं पाणी भरपूर हेडवरनं आल्यामुळं ते वेगानं आतमध्ये सर्क्युलेट केलं जातं. गाईडवेन्स ज्या आहेत, गाईडव्हील आणि गाईडवेन्स फिक्स असल्यामुळं पाणी आतल्या साईडला ज्यावेळी घुसतं त्यावेळी त्याला दिशा दिली जाते आणि हे दिशा दिलेलं जे काही पाणी आहे ते रनरच्या व्हेन्सवर वेगानं आदळतं आणि ते आदळल्यानंतर रनर फिरायला सुरुवात होते. रनर जोरात फिरायला सुरुवात झाल्यानंतर त्याला जोडलेला जो शाफ्ट आहे तो शाफ्टही जोरात वेगाने रोटेट होतो आणि तो शाफ्ट जनरेटरला अटॅच केलेला असल्या कारणानं तिथं इलेक्ट्रिसिटी जनरेशन होतं. आफ्टर सर्क्युलेटिंग ऑल दी वॉटर, दी रिमेनिंग वॉटर इज टेकन outside from the draft tube and it is sent to the tail race, and from that tail race it is moving in the desired location. Is it understood to you?
Yes sir.
Yes, sir.
पंप मध्ये वेगळं होतं. पंप मध्ये काय होतं, पंप मध्ये पाणी घेतलं जायचं, सेंटरला पाठवलं जायचं आणि सेंटर मधून ते पाणी स्पायरल केसिंग मध्ये जायचं आणि तिथून ते पाणी बाहेर काढलं जायचं. इथं टोटली रिव्हर्स मेकॅनिझम आहे. इथं पाणी आतमध्ये वरून घेतलं जातं, गाईडवेन्स मधनं ते गाईड केलं जातं आणि रनरवर स्ट्राईक होतं, रनर वेन्सवर, आणि रनर वेन्स जे आहेत ते मूव्ह व्हायला सुरू होतात. सो दॅट युअर रनर इज ऑल्सो रोटेटिंग, शाफ्ट इज कनेक्टेड टू दॅट पर्टिक्युलर रनर and that shaft is attached to the generator also. So this is the mechanism of our Francis turbine. I want to show you, here you can see हा जो सेंटरचा शाफ्ट आहे, हा शाफ्ट इथं या ठिकाणी जनरेटरला जोडलेला आहे. आतमध्ये याच्या जे काही आहे ते मेकॅनिझम आहे रनरचं, ते फिरतं, ते फिरलं की इथं शाफ्टही फिरतो, शाफ्ट फिरल्यानंतर इथं एनर्जी जनरेशन होते and that energy is taken outside for the electricity generation purpose. So this is about the Francis turbine, and here you can see the flow is moving towards inward direction. In centrifugal pump, flow was flowing in outward direction. Okay, centrifugal pump मध्ये पाणी बाहेरच्या दिशेने वेगाने ढकललं जात होतं, इथं पाणी आतल्या साईडला वेगाने ढकललं जातं. That is the basic difference in between centrifugal pump and this Francis turbine. Structure is little bit same, but working is totally different. Is it understood to you?
Yes sir.
So
Yes,
I request you, draw this diagram in your notebook without wasting much of time. Diagram is very easy. Okay, so don't take a lot of time because we will have to discuss many points regarding with this Francis turbine. So I request you,
Sir?
your time is started now. you can draw it immediately. And I think you got the differences between Francis turbine and centrifugal pump construction also. MCQ may be asked on this particular concept. The reversed mechanism of centrifugal pump is used in compressor, turbine, and two more options. In that case, you will have to write it in turbine. And in which turbine? Francis turbine. Have you drawn it?
No,
Yes,
sir.
sir.
Okay, draw it. This figure is very important. And always keep in mind, outer wheel is guide wheel and outer vanes are guide vanes. Guide vanes are fixed and runner vanes are movable. They are moving in a rotational direction. That part you will have, you should not forget, because question may be asked. In the Francis turbine, guide wheels are moving, fixed, rotating, and another one option may be there. In that case, you must write guide wheels are fixed and runner vanes are moving. Don't make it reverse, otherwise your turbine may not work. If guide vanes are running and runner vanes will be fixed, then turbine will not work. Okay, so always keep in mind, guide wheel and guide vanes are fixed, runner and runner vanes are moving.
सर
Okay.
रनर मधून वॉटर ड्राफ्ट ट्यूब मध्ये कसं येईल?
आता हे this diagram is 2D diagram. Okay. I
Yes,
want to
sir.
show you. I will draw it. So suppose this is the spiral casing. इथून तुम्ही पाणी आतमध्ये घेता. राईट?
Yes, sir.
आता ही डायग्राम समजते का बघा, मी साइड व्ह्यू काढतोय. दिस इज द गाइड व्हील. गाइड व्हील आहे. इकडच्या बाजूने बघा, या पंपला, सॉरी या टर्बाइनला या बाजूने जर तुम्ही पाहिलं, ओके, तर कसं दिसेल? देन हियर इनसाइड देयर विल बी रनर. दिस इज द रनर व्हील. Okay, so water is taken inside and runner is moving. Water is traveling towards the center and then that water is taken out in this way. म्हणजे जर हा केसिंग असेल तुमचा, तर इथं ड्राफ्ट ट्यूब लावलेली असते in this way. Okay?
Yes, sir.
थोडस समजायला डिफिकल्ट आहे. हा साइड व्ह्यू आहे. फक्त एक लक्षात घ्या, ही जी ड्राफ्ट ट्यूब आहे ना, पाणी इथं आतमध्ये गेलं तर इथून हे असं मागच्या साईडला ड्राफ्ट ट्यूब आहे, तिथून पाणी या ड्राफ्ट ट्यूब मधनं खाली आणलं जातं. इन द एनिमेशन आय थिंक इट विल बी क्लिअर टू यू.
Sir, figure काढून झाली.
डायग्राम इज ओव्हर.
Over.
Yes, sir.
Just a minute. Let us check whether animation is available. Yes, it is available.
Turbine. Which are the parts?
Whether sound is audible to you?
Yes, sir. Today we will discuss about the Francis turbine. Which are the parts of the Francis turbine and how it will work. Firstly, we will discuss about the runner of the Francis turbine. Runner of the Francis turbine has vanes. This is the top view of the runner. In the runner, water will come in the radial direction and will go outside in the axial direction.
See, don't concentrate on upper diagram, concentrate on lower diagram. So water is coming and striking on this particular runner part. So water is coming over here and striking on this runner vanes, and this water is coming to that runner through the guide vanes. ओके, तर ते रनरवर इथं येऊन अशा पद्धतीने आदळतं आणि इथून ते आतमध्ये सेंटरला जातं ऍक्च्युअली. आता तुम्ही जर टॉप व्ह्यूला बघितलं म्हणजे वरून जर पाहिलं तर तुम्हाला असं दिसेल की पाणी अशा पद्धतीने रनरवर आदळतं आणि तिथून ते खालच्या दिशेने जातं. जो मला प्रश्न आहे की ड्राफ्ट ट्यूब कडे पाणी कसं जातं, तर ते आदळून ग्रॅव्हिटीमुळे खालच्या डायरेक्शन कडे मूव्ह होतं.
This is the casing for the Francis turbine, in which our runner will be installed, and over the runner we have guide vanes. These are the fixed vanes which will guide the water for rotating in the runner. Now we see the working of Francis turbine. What will happen when water will come radially and go outside with the axial direction? Then rotor will start rotating. Now we see this working in this casing. When water will come through the casing, it will rotate in the casing, and by the rotation it will enter in the guide vanes. From the guide vanes it will enter in the runner blades and runner will start rotating. The pressure and kinetic energy both are used in the Francis turbine for rotating the runner. Now we understand Francis turbine working with another figure. In this figure, we can clearly understand the working of Francis turbine.
So I think now you might have understood how water is taken inside and send it to the runner through the guide vanes. Guide vanes मधनं रनर कडे कशा पद्धतीने ते पास केले जातात. गाइड वेन्स मुळे पाणी जे आहे ते रनरवर जाऊन आदळतं, हे लक्षात घ्या. सो इज इट क्लिअर टू यू पीपल?
Yes, sir.
Yes, sir.
Now to clear the doubt regarding with it's a draft tube, I want to show you the actual experimental model of a Francis turbine. And
Hi,
here you
I'm
can
Jeff
see
Goldmere, GE's fuel guy.
And I'm Simon Blakey, the IHS market energy expert.
Francis
Today we want
turbine,
to talk.
actual model.
नमस्कार दोस्तों, मैं प्रकाश
This
कुमार
is the
सिंह,
model.
मैं आज आपको बता रहा हूँ फ्रांसिस टर्बाइन. दोस्तों फ्रांसिस टर्बाइन क्या होता है?
So here
Hello.
कुछ एनर्जी वेलोसिटी हेड से प्राप्त होती है और कुछ एनर्जी प्रेशर हेड से प्राप्त होती है. तो इस तरह टाइप के टर्बाइनों को रिएक्शन.
So here you can see the draft tube. One girl was asking about the draft tube. So this is our, we can say that Francis turbine. Water is taken inside. Here there is a pipe. Can you see? Hello?
Yes, sir.
Yes, sir.
So water is taken inside, it is get rotated and it is moving towards center. And once it is reaching the center, it is taken out through this draft
टाइप के
tube.
टर्बाइन कहते हैं.
You can see the draft tube over here. This is the water outlet. And you can see here, the dimension is increasing towards the tail race. डायमेन्शन असं वाढत चाललेलं आहे पहा थोडं थोडं लाईटली. सो तुम्ही जी डायग्राम बघताय 2D डायग्राम ती इथून बघताय, समोरून बघताय. And that's why this draft tube is visible at the back side. But if you will see from one side, you will come to know that water is taken inside over here. It is get rotated, and from reaching towards center, it is taken outside through this particular draft tube. Have you understood now?
Yes, sir.
Draft tube कुठं असते कळलं तुम्हाला?
Yes, sir.
तुम्ही जर इथून ही डायग्राम बघितली तर तुम्हाला आपण दिलेली 2D डायग्राम कशी आहे तसं दिसेल. ओके. आणि ही जी ड्राफ्ट ट्यूब आहे, ह्या ड्राफ्ट ट्यूब मधनं जे काही सेंटरला आलेलं वरनं घेतलेलं पाणी जे सेंटरला येतं ते बाहेर काढलं जातं. दिस इज द मेकॅनिझम.
तो इसके अंदर कौन कौन से पार्ट्स होते हैं, वो किस तरीके से वर्क करते हैं, तो मैं आपको पहले इसके बाद, ये डिस्चार्ज प्रेशर गेज रहता है. इसके बाद पानी इधर से एंट्री करता है, एंट्री करने के बाद ये मूव करेगा, मूव करने के बाद पानी सेंटर से निकलता है, फिर ये नीचे जाएगा. ये बेंड ट्यूब रहती है, ये ड्राफ्ट ट्यूब रहती है. ड्राफ्ट ट्यूब क्या वैक्यूम क्रिएट होता है, उसकी वजह से वैक्यूम क्रिएट होता है, तो वैक्यूम प्रेशर यहाँ पर दिखाता है. तो जब चालू करेंगे तो मैं आपको वैक्यूम प्रेशर भी दिखाऊंगा किस तरीके से, डिस्चार्ज प्रेशर भी दिखाऊंगा. इसके बाद इसके ऊपर जो लोड लग रहा है, तो ये रो ब्रेक डायनोमीटर है, लोड मेजरमेंट करने के लिए इसका यूज किया जाता है. यानी फ्रांसिस टरबाइन का आउटपुट पावर कितना निकल रहा है उसको मेजर करने के लिए, इसकी इफिशियंसी को निकालने के इसके यूज किया जाता है. तो इसके अंदर कौन कौन से पार्ट्स होते हैं उसके बारे में आपको जानकारी. उसके वो स्टेनलेस स्टील या कास्ट आयरन की बनी होती है. तो सबसे सेंटर से पानी निकलेगा, सेंटर से इधर निकलने के बाद बेंड ट्यूब से होता हुआ ब्लेड से टकराता है. ब्लेड से टकराने के बाद रोटर मूव करता है. पेन स्टोक, ड्राफ्ट ट्यूब्स, इन सब का क्या काम रहता है. तो आरपीएम कम होने पर, लोड बढ़ने पर कितना आरपीएम कम होता है.
This particular Francis turbine machine is available in the fluid mechanics lab. This video I have just shown you to show you about the construction of the draft tube. Okay, that doubt was asked, and I think now the concept regarding with this Francis turbine is clear to everybody. Is it clear to everybody, or any doubts are there?
No, sir.
Okay, can I move ahead?
Yes, sir.
Okay. So friends, here there is some points, important points regarding with this Francis turbines are mentioned over here. So I request you to write it down in your notebook. Give the heading Francis turbine. Francis turbine. It is inward flow reaction turbine. It is inward flow reaction turbine. It is inward flow reaction turbine, which is suitable for which is suitable for 50 meter to 250 meter heads, which is suitable for 50 meter to 250 meter heads. Which is suitable for 50 meter to 250 meter heads. Full stop. Next point. Main components. Main components. Main components. Number one, scroll casing. Scroll casing. Number two, guide mechanism. Guide mechanism. Number three, runner and shaft. And number four, draft tube. Next point. Water enters through penstock. Water enters through penstock in scroll casing. Water enters through penstock in scroll casing which is spiral in shape. Which is spiral in shape. Which is spiral in shape. Next point. Casing surrounds guide vanes, comma, runner, guide vanes, comma, runner, comma, shaft, etc. Comma, shaft, etc. Next point is casing and runner. Casing and runner. Casing and runner are always full with water. Casing and runner are always full with water. Full stop. Guide vanes are fixed. Next line. Guide vanes are fixed. Guide vanes are fixed. And runner vanes are movable. And runner vanes are movable. And runner vanes are movable. Next point. Guide vanes directs water. Guide vanes direct water. Guide vanes directs water to enter runner. To enter runner for smooth and shockless entry. For smooth and shockless entry. For smooth and shockless entry. Written?
Yes, sir.
Yes, sir.
Next point. Water flows over runner. Water flows over runner radially inwards. Radially inwards. Radially inwards. Radially inwards. Full stop. moving vanes further convert pressure energy to kinetic energy. Next line. Kinetic energy of water imported to runner, kinetic energy of water imported to runner is converted to mechanical work, And the last point of Francis turbine is finally water is discharged through draft tube. Water is discharged through draft tube. Water is discharged through draft tube. Have you written all the points related with the Francis turbine?
Yes, sir.
Yes.
Have you drawn the diagram?
Yes, sir.
How Francis turbine works? Is it clear to you?
Yes, sir. Yes, sir.
How Francis turbine is having totally reversed mechanism than the centrifugal pump? Is it clear to you?
Yes, sir.
Yes,
Yeah.
sir.
So friends, today we will stop here only. We have studied today the construction and working of the Francis turbine. Now, in the next lecture, we will move towards the final concept of our unit number 5 pump compressor turbine, that is Kaplan turbine. Okay, and then our syllabus for the unit number 5, that is unit test number 1, is going to be concluded over in the next few lectures. So time being, I'll stop here only. Thank you for being with me. Have a nice day. Do study hard for unit test. Thank you very much and bye-bye.